Hello, everyone. I apologize for this coming out late. As in my previous email said, I had other errands to run. My parents are 71 and 68, so I was not going to let them go to the grocery store with everything going on. So I got to spend a good part of my day doing errands for them. As for you guys, so the way we're going to approach this week is since we're supposed to meet on Monday, Wednesday, and Friday, there's going to be 3 activities, but I know everyone's schedule is a giant question mark and it's different. So I'm going to release all 3 activities at once. This is on Moodle, and you can kind of take it from there. So the first thing is the electric force is what I'm going to be talking about today, very briefly. So what we see here is a mathematical representation of the electrical force. But essentially what we're talking about is we're going to say here's a positive charge. And let's make another charge for him. We'll call this one a negative charge. So if I go, say this one is negative, this one is positive. Hopefully by now you know that these two are going to attract each other. So the forces would draw them closer to one another. If instead I had 2 positive charges, positive, positive, they would repel each other. And if I had 2 negatives, they would repel each other as well. Now, because we use positives and negatives for direction in our mathematics, we are actually going to not worry about whether our charge is positive or negative when we solve the mathematics, as you can see the formula here. The whole thing is in absolute values because we do not care whether our charge is positive or negative. We're going to assign direction to be positive or negative later on. So in this equation, you see a lot of different things. Let's break it down for you. Fe, that's the electric force. The electric force, like all forces before it, are measured in newtons. K is a fundamental constant. It is 9 times 10 to the 9th. Q1 and Q2. So the letter Q stands for charge. C was already taken for capacitance, so Q was left over for charge. We measure charge in a unit that we call coulombs, and coulombs is abbreviated with a capital C. And R, last bit, is their separation distance. I have included some notes as well that show some example problems for you and how that these things are resolved. From there, there's a pretty simple WebAssign, which give it a shot. Again, as always, as we're going through this, none of this is required, none of it is mandatory or expected. So do what you can, and if you can't, whether you just don't understand it or you have too much going on, that's totally fine. That's not a big deal. You don't need to let me know. But otherwise, for those of you who are, well, good luck.